Welcome back. We're going to start talking about ethers, our last chapter this semester. And this chapter starts different than the other chapters in that physical properties is talked about first. That's usually near the end if it's discussed at all. And it's because ethers are kind of unique. An ether has two carbon groups, one on each side of an oxygen. And you remember a bond between carbon and oxygen is polar covalent. To say, well, they should have some polarity, right? Well, if you think about it, the net is just a tiny bit up. Not very polar. So, low BPs and MPs. If you got low intermolecular forces, then you have low boiling points and melting points. So you'd probably think, oh, because it's not very polar, it doesn't dissolve in water very well. Well, that's where you might have a problem. Unlike things like pentane, which is almost zero water solubility, for obvious reasons. It's a non-polar molecule, doesn't have a single polar bond. And ethers, like diethyl ether, roughly 9% water solubility. That's quite a bit different. It's about 20 times more water soluble than pentane. So that's roughly zero water solubility, 9% water solubility. How can this be? Non-polar molecules shouldn't have water solubility. And the answer is right here. Even though an ether cannot hydrogen bond with itself, because it doesn't have a polar H bonded to something, it can be a hydrogen bond acceptor with water. Two lone pairs, same story, both directions. It's an H bond acceptor. And that gives it some attraction to water to the extent of you can make about a 9% ether solution in water. Whereas the boiling points of pentane and ether, almost the same boiling point, within 2 degrees of each other. Why same boiling point? They're both pretty non-polar. And why higher water solubility for the ether? Well, hydrogen bond accepting with the water. And that's all you need to know about physical properties of ethers. I generally don't even test on it. Nomenclature we will see. So let's do some simple ethers. We'll look at UPAC names and common names. Just turned off again while I was writing. UPAC's strange. It's methoxymethane. What? Common name makes more sense. That's not always true, is it? Dimethyl ether. How about this one? This one's methoxyethane. What do you think methoxy means? And its UPAC common name would be ethyl methyl ether. Three words. I like the common name. You just name the groups on each side, right? Alphabetically. Alphabetical. E before M. Here they were the same group, just say there's two of them. A methoxy is a group that's like a methyl, but it's attached by way of an oxygen and not by way of a methyl. Oh, let's see if you just caught that. Let's do the common name of this one, or the UPAC name of that one. And let's throw another group on here just for fun. There we go. This UPAC says longest chain is heptane. How much room I need here? Name all the groups on heptane. There's an ethyl on 5. What's that group on 1 called? Propoxy. Oh, I think we have a method of naming thousands of different new groups, don't we? Propyl is here. 1, 2, 3, propyl, but it's not connected to the heptane through the carbons, through an oxygen. So it's propoxy. 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 Methyl, oxy, methoxy. Now, how come I didn't call it ethoxy methane? Well, UPAC says you need the longest chain. 2 is longer than 1. The parent is the ethane. The other smaller piece is the group. And there's the methoxy again. And what would be the common name here? Propyl would be the second word, I'm almost positive. You have to have an ether word at the end. Maybe do something like this with acetylene. Yeah, we named the two groups on each side of acetylene. This is the same. Compare with naming acetylene. Compare with naming acetylene. Common naming. Oh, Lord. That's why I said that. Computers. Can't live with them or without them. Naming of acetylene. Chapter 7. Okay. So what's this group on the other side of the, it's a pentyl group, 1, 2, 3, 4, 5, 6. No, it's a heptyl group with an ethyl on 5. 5-ethyl heptyl. That's the name of the group. Three words. This one starts with an E. This one starts with a P. Ether has to be at the end. 5-ethyl heptyl propyl ether. Some naming ethers isn't bad. Let's do another one to finish up. Yep. And let's have that with an O. Right there. Longest chain. 3, 4, 5, 6, 7. Stuck on heptane here. Let's at least make it octane. Octane. What's that group on carbon 3? It's not a cyclohexyl group. Cyclohexyl is now cyclohex. What do? You changed methyl to methoxy. Changed propyl to propoxy. You lose the ill and replace with oxy. Hexyl becomes hexoxy. And you know I love that when you start putting X's close to each other like that. 3-cyclohexoxy. Let's make sure that's clear there. A little surgical white out here. And that's the end of the X there. And that's the start of the Y. There we go. And there's a stereocenter that makes this R. Common name, cyclohexyl. Three-octyl. R3-octyl. Ether, new word. And that's about as much as I want to do with nomenclature of ethers. So there's a bunch of titles here at the end. This will be our last one. I know it'll end us early, but I've got a lot of things to do, and so do you. So we'll just stick with epoxides. It's not that short a segment. They are very important in synthesis. Very important in synthesis. We only scratched the surface of synthesis in this class. Synthesis, your knowledge of it will explode in Chem242. Epoxides are cyclic ethers. Cyclic ethers, ring size equals 3. So the simplest one is this. And its name may confuse you. It's got two names. The UPAC name and the common name, at first, neither one makes sense. It's got ethylene in its name. And you guys are saying, I don't see a double bond. I see the 2 carbons. I'll give you that. I do not see an alkene. And that's covered by the end of the name, ethylene oxide. And the common name makes even less sense. Oops. Makes even less sense if you don't spell it right. Oxyrane. Oxyrane. And it's a heterocycle. What does that mean? It means it's got a ring with one of the atoms not being carbon. Makes sense. So cyclohexane was just a normal cycle. We didn't even say normal cycle. That's all we knew. But now I say, oh, one of the corners is an oxygen. It's a heterocycle. The heteroatom, this is true for other heterocycles too. And I'm going to remind you, this is not our first heterocycle. The heteroatom is atom, and this goes against everything you've learned in nomenclature, number 1. Okay. So over here, when you call it oxyrane, you've covered just the triangle. Now you got to tell me there's a methyl on this carbon, and you have to tell me what number it's on. 2-methyl. Why? Because atom number 1 is the oxygen. And now that looks like a B there, doesn't it? Trust me, I understand. Making things not look like B's and P's. Very important, especially where I teach. Methyloxyrane. And that because number 1, 2, 3. There's the methyl. And the UPAC name's easy. Propylene oxide. So when you're naming these as the oxides, just remember, ethylene oxide comes from the parent H2CCCH2. Yeah, ethylene. It's no longer ethylene. It's been converted to an epoxide by putting an O up there. And the parent was H2CCH3. You can draw it this way if you want. Propylene. By adding oxide at the end, you're saying, okay, this alkene was used to make that epoxide, which is actually true. Will be a focus of Monday's lecture. They come from alkenes. That's how their name even implies that when you use the UPAC name. And we'll do a couple more. Let's do this one here. And that would be called, what's the parent? So pretend this is a big question box. And what's the parent? Well, the alkene that it came from was this one. And that's 1-ethylcyclohexene. And how do you say now it's an epoxide? Add oxide. But this is only one isomer. You have to also tell me about, yeah, these old stereo centers, they never go away. And 1 for an O, 2 for a C that has an O, 3 for a C without an O, 4, and this, don't forget this is carbon number 2, and it's definitely R. And we'll go to this one. 1 for the O, 2 for carbon with an O, 3 for carbon without an O, 4 for ethyl. And that one is S. And there you go. Pretend the box was smaller. So naming of epoxides. And I wouldn't even try to call this an oxyrane. What are you going to do? Say the oxyrane has a cyclohexane glued to it? Do you know how to do that? I don't think so, and I'm not going to teach you. So sometimes you got to use this name, the UPAC. There's always a way to do the UPAC name. There's not always a way to do the common name. And I just want to look at this, the heading for this next one. Synthesis of ethers. I'm looking at the clock. The reaction segment of chapter 11 will be our only focus on Monday and will be finished in an hour. How's that? That's my goal. And then that will end the semester. And I look forward to seeing all of you on Monday. And good luck with your owls and all of that. And bye.